Now, using the specific pictures, we can do cool things with it. We can do some, we call them transformation. Transformation is like, suppose you don't know the meaning of a word, but you remember the prefix or the suffix. For example, you know what possible means, but you don't know what impossible means. So just remember, it means not. Or so when you what patient means, so impatient, so you can take that word and you can find the meaning of a new word, so using suffix and prefix. So that's how can you extend your vocabulary. So if you consider this Cartesian coordinate system as some sort of learning a new vocabulary of how to draw pictures, then we have mainly these vocabulary. We call them transformation. The first one is flip. You take a picture and you flip it. We also call it reflection. Reflection. For example, if you take a picture like this, you know what the original picture looks like. So y equals to x, you know what it looks like. But if you have a number like this, x negative in front of it, it means it's a flip. So you take it and you flip it. This is what it looks like. Doesn't matter how you flip it, this is what it looks like. You can reflect it on the x-axis and this is what it looks like. Then you have y equals to minus x squared. So the flip would look like this. So you have to start with the original, what the original looks like, and you just flip the parabola. Next, when you have minus x cubed, you flip it and it looks like this. That's it. This is what the flip looks like. Then we have y equals to 1 by x. So the flip looks like here, here and here. This is where the two hyperbola would be. So that's a flip. Now, the other ones, they would be a bit different. For example, there are two different flips with e to the power x. One of the flip is like this. If you have y equals to minus e to the power x, the flip is like this. The original picture was here. You would just take it over here. You flip it on the horizontal line, or you flip it over the x-axis, or you can call it reflection on the x-axis. So this is what happens. The flip is like this. On the other hand, if you have y equals to e to the power minus x, the flip is with the y-axis. So the original, always start from the original. The original is around here. So the flip would be like this. So this is what the flip looks like. So remember, with e to the power x, there are two different flips if you have this and this. Now, what about if you have double flips? So if you have minus e to the power minus x, there would be double flip. So we can start step by step and see what that double flip looks like. So this is the original. This is the original y equals to e to the power x. And the first flip is from here, reflection on the x-axis. So this is the first flip, and the next flip is reflection on the y-axis. So the next flip would be, you take this and flip it around. So this is the final picture. This is what the final picture looks like. So when you have y equals to minus e to the power minus x, the picture, you can flip it in your mind or you can just memorize it. The picture looks like this. So minus 1. So this is what the picture looks like. This is what the picture looks like. Now, the same thing, remember with logarithm. So with logarithm is that when you have y equals to minus x, so the flip would be, remember, so if there is a negative in front in e to the power x and ln x, so the flip is on the horizontal line. So the picture would be like this. So you flip it around the x-axis. So this is what the flip looks like. Now y equals to ln minus x, that is not possible. There is no flip around that, so that question will not be asked. And we have one more flip. If we have y equals to minus sine x, so the flip would be, so this was the original, so this is what the flip would be. So that's it. So minus sine x. And so minus cosine x, the flip would be like this. That's what the flip would be. That's it. So reflections or flips, that's how you flip the picture. The next sort of transformation is it's a slide. That's a very common transformation. You slide things around. So the next one is slide. Or we can write it down like this. Fx plus a. It either slides upwards. Fx minus a, you slide downwards, remember. So when you have a picture like this, y equals to x squared plus 3. You slide the picture upwards. That's it. You start from the original picture y equals to x squared and you slide it upwards. So it would be like this. When you have x squared equals to minus 3, you slide it downwards. So originally it was at 0. It would be here minus. Of course, now we wouldn't know what these are. It's not possible from this sliding. We have to find it out by, other means. For example, putting y equals to 0. So then it would be x squared minus 3 equal to 0 would be an equation. So we have to find plus minus square root 3. So that's how we have to find it. But otherwise, by sliding, we will not be able to know what this is. Then we can slide around x cubed plus 1. So then the entire picture goes up. So this is 1. If you have x cubed minus 1, the entire picture goes below and it cuts here minus 1. It's pretty easy, straightforward sketching. And here again, you wouldn't know where it's cutting here unless you put y equals to 0. Then you'll find out this is 1. And other slide we have when you have a y equals to 1 by x, suppose plus 2. Now this one is going to be a little bit difficult because you see the original picture y equals to 1 by x, it's made up of two broken lines or asymptotes. So this is what the original picture looks like. Now if you have y equals to 1 by x plus 2, it's going to slide upwards. If it slides upwards, that means the original asymptote is going to move upwards. You can see the asymptote over here. So the asymptote was initially at 0, but since it slided upwards, this would become 2. And the boomerang would look like this, and the other one would look like this. So that's why this is a bit difficult. Or if it was y equals to 1 by x minus 2, then from the original picture, it would slide downwards. So this asymptote would go here, minus 2, and you would have this boomerang over here and this one over here. So when you have this type of slide, it's a little bit difficult with the broken line. Then the same thing when we have with e to the power x. So when we have e to the power x, so suppose you have y equals to e to the power x plus 1. Again, we have, remember, the original picture has an asymptote with it. So e to the power x plus 1 means when it slides upwards, the asymptote would move upwards. So this one would be 1. And the picture would be this. So previously it used to cut the y-axis at 1. Now it would cut the y-axis at 1 plus 1, 2. Because it slided upwards. And if you have y equals to e to the power x minus 1, then what would happen? The asymptote would slide downwards. And the picture would be like this. And here it would cut. Previously it was 1, so it would now go through 0. Yes, it would go through 0 because previously it got 1 unit sliding downwards, it would be through 0. And in case of ln x, when you have y equals to ln x plus 1, remember it's difficult to see the slide because the original picture looks like this. If it moves upwards or downward, you're not going to be able to see what happens. So it's difficult to see. So when you have sketching, the most common slide transformations are this one, quadratics, cubics. These are the slide question, or e to the power x. These are the common slide question, or even this. So these are the common slide questions. Now there's another type of slide. So far I showed you a vertical slide. There is a horizontal slide over here, like this. So this time with x plus a. Now this is a bit reversed. When you have x plus a, the a is inside of x. So if it is plus, you move it left, towards the left. If it is minus, you move it towards the right. It's reversed. So what is the difference between the previous slide? Well, the previous slide was outside. This one, it would be x plus a whole squared. So it's inside the square. So x plus a whole square means starting from the original picture. Remember, the original picture is a parabola like this, y equals to x squared. So x plus a means it is moving towards the left by a unit. So the picture starting from 0 over here, it would be here minus a. It would move towards the left. When you have y equals to x minus a whole squared, it moves towards the right. So the picture would look like here. It would move towards the right. When you have y equals to x plus a whole cubed, then you have a slide towards the left. So now you can easily figure out. So this would be here, minus a towards the left. When you have y equals to x minus a to the power 3, it would slide towards the right. So the slide, it would be here. Okay, now if you want to find out where does it cut the y-axis or x-axis, you have to find it differently by putting the value of y0. Cutting the x-axis means y0, cutting the y-axis means x0. You have to find it differently. But by the transformation of sliding, you have to figure out only by these things. Now, we can do the sliding also for this one. Y equals to 1 by x plus a. Remember the hyperbola? So the original picture is like this. Okay, so this time the vertical broken line or the vertical asymptote would slide towards the left. So the picture, the picture would look like this. This would move or slide backwards by a unit. So this would be minus a, and the boomerangs would look like this. And if you have y equals to 1 by x minus a, which means a slide towards the right, so the vertical asymptote now would move towards the right, and it would be a here, and you would have a boomerang over here and the boomerang over here. So that's what the slide looks like. Now, we don't have a slide for e to the power x. Remember, we're talking about the most common questions. And a slide of y equals to ln x, y equals to ln, suppose x plus a, would be like this. The vertical asymptote, remember, this is what the original ln x picture looks like. It will slide towards the left. So if it slides towards the left, this is where the asymptote would move to. From 0, it would move to minus a towards the left, and the picture would be like that. So since previously it cut at the point 1, it would move a unit, so it would be 1 minus a. That's what the value would be. So it would slide towards the left. And similarly, if it x minus a, it would slide towards the right. So the sliding of y equals to ln of x minus a would be like this. The vertical asymptote is here. So this is a now. And the sliding would be over here. So previously it was 1. It would be 1 plus a. So it's very, very important that you remember the original pictures. You always have to start with the original pictures. This is like memorizing some words. Even if you don't know the word of the meaning of the word in detail, or you do not speak that unknown language, just by memorizing some of the word what that means, you can have some idea of that language. So it's a good idea to memorize these pictures, and from that you can do the other, form new words of the sliding and the flipping. And one last transformation that we have is stretching. So this one is stretching. S-T-R-E-T-C-H-I-N-G. Stretching, or just stretch. So here we write it like a-fx. We multiply it with a number. And let me tell you beforehand, stretching has no effect at all on these pictures. Y equals to x makes no difference. Stretching means, just multiplying it with the y coordinate with a. It doesn't really matter. So y equals to 2x, y equals to 3x, y equals to 4x, y equals to x. Well, it's not, when you sketch it, it's not that apparent what happens. You just stick to this. That's the rule of thumb. Stick to the same picture. Then y equals to x squared, since again it cuts the x-axis and y-axis at 0. So it doesn't matter. Y equals to any number x squared, y equals to 2x squared, y equals to 3x squared. Makes no difference. The picture is the same. Unaffected. Y equals to x cubed. So y equals to x cubed, unaffected, doesn't make any difference at all. So it comes in handy to remember that. Then y equals to 1 by x, or y equals to a into 1 by x. Makes no difference. Y equals to 2 by x, y equals to 3 by x, y equals to 4 by x. The picture is the same. It's like this. The two boomerangs like that. Then y equals to e to the power a to the power x. Now this is affected. Y equals to a to the power x, because we know the picture cuts the y-axis at 1. If you multiply by a number, the stretching, it would be multiplied with 1. So that means y equals to 2e to the power x means it would cut at 2. Just memorize this. Y equals to 3 to the power x. That means it would cut at 3. That's it. Y equals to 4e to the power x. It would cut at 4. So that's it. That's how the stretching works. And this would also work with uh, y equals to ln x. If you have a ln x, so does it cut the y-axis? No, it doesn't cut the y-axis at all. So it makes no difference. It's the same. So this one, this one, this one, this one, the pictures that does not cut the y-axis, it will not be affected by this stretching of AFX. But the picture that do cut the y-axis would be affected. So these would be, to the power x would be affected. Everything else will not be affected. For example, y equals to a sine x would be affected. Previously it is plus 1 and minus 1. This is plus 1 and this is minus 1. So it would be a and a. This would be plus a and this would be minus a. That's it. That's all. That's how sine x would be affected. Cos x will be affected. Previously cos x was just plus 1 and minus 1. Now it will be plus a and minus a. So this will be plus a and this would be minus a. So there is one more type of stretching. This is stretching horizontally. This type of stretching is, it's like this. FAX. This time you stretch it such that you divide the x coordinate with a. That's sort of a stretching. This is also doesn't really, it's not a big deal because it doesn't matter, because the picture would not be affected. So what pictures would not be affected? Pictures that do not cut the x-axis anywhere other than 0. So y equals to x will not be affected. Y equals to x squared will not be affected. Y equals to x cubed will not be affected. Y equals to 1 by x will not be affected. This time even y equals to e to the power x will not be affected, because you see, when you have y equals to e to the power ax, it does not cut the x-axis. So the picture would be same. Doesn't matter. If you have y equals to e to the power 2x, y equals to e to the power 3x, y equals to e to the power 4x. Of course, there are some subtle changes, but when we are sketching, the rule of thumb is just draw the same picture. Doesn't matter. This will not be affected because it doesn't cut the x-axis. Whatever cuts the x-axis, the stretching would affect there. Whatever cut the y-axis, the stretching would be affected by AFX. So it will not be affected. And so that's that. Another thing that will be affected is y equals to ln x. So when you have y equals to ln ax, now this one you need to remember this special situation. So originally the picture would be like this. It would cut at 1. But if it is y equals to ln ax, ln 2x, ln 3x, ln 4x, what we do, we divide the value of x with a. So if it is ln 2x, it would be half. If it is y equals to ln 3x, it would be 1 by 3. If it is y equals to ln ax, it would be 1 by a. So that's all that you need to remember.